Functions whose equations contain a variable in the exponent are called exponential functions. Many real-life situations, including population growth, growth of epidemics, radioactive decay, and other changes that involve rapid increase or decrease, can be described using exponential functions. The exponential function with base b is defined by f of x equals b to the x power, or in other words, y equals b to the x power, where b is a positive constant other than 1, and x is any real number. Some examples of exponential functions are things like f of x equals 2 to the x plus 1 power, or something like y equals 3.9 times 5 to the x power. The value that has the exponent on it is referred to as the base. So here 2 is the base and 5 is the base. Notice that 3.9 is not affected by the exponential x. The graphs of exponential functions always look similar to each other. The graph of any rational function can be obtained by transformations from one of the following two graphs. Okay, so depending on your value for your base, if your base is greater than 1, then your exponential function will look something like this. Okay, notice on the left it's relatively flat, and then as we move to the right, we get a gradually more steep graph. Okay, if your base is between 0 and 1, then your graph will look very similar to this, except backwards. It will look something like this. Again, notice on one end we've got a very steep graph, and on the other end we have a graph that's flattening out. So this is why we say that exponential functions are very good at modeling rapid growth or rapid decay, because we see this very steep graph that gets more and more steep as we move along. When modeling many real-life situations with an equation, the same number often appears as the base of the exponential, and it's the rational number e whose value is approximately 2.71828. Please note that there's a e button on your calculator for this. We call e the natural base, and f of x equals e to the x is called the natural exponential function. So example 1, the gray wolf in the United States was hunted almost to extinction. The exponential function f of x equals 1.26 e to the 0.247 x power models the population of the gray wolf in the northern Rocky Mountains X years after 1978, when it was added to the endangered species list. If the growth trend continues as it has been, according to the model, what will the population of gray wolves be in 2015? Okay, so we have a year, and we're asked to figure out a population. So this is a matter of putting an x value into our function. Okay, but be very careful with which x value you put in. You don't want to put in 2015 because it says x is the years after 1978. So the x for our problem, we're asked to do 2015, and it's the years after 1978. So you would want to subtract 1978 from 2015, and if you do that, you get that this is 37 years. So 37 years have gone by. So to answer this question, we need to put 37 into our function. So f of 37, 1.26 e to the 0.247 times 37 power. So on your calculator, we would have 1.26 times, your E button is right here. You'll have to hit second, and then your E button, 0.247 times 37, and press enter. and we get 11,732.42. Okay, we're talking about wolves. You can't have a fraction of a wolf, so we would round accordingly. And 11,732 would be our final answer.